Determine where a function has a horizontal tangent. Well, before we can figure out where a function has a horizontal tangent, we should probably do a quick review of horizontal tangent lines. And if we remember back in algebra, we had learned that horizontal tangent lines are constant functions. And the reason we know that they are constant functions is because their height never changes, which forms a horizontal line. So as you can see on this graph, y equals c, where c is just any number, is going to be a constant function. And if we dive a little bit deeper into our previous knowledge from algebra, or if we just look at this line, we can see that this particular function has a slope of 0. So since the y values never change, we never increase or decrease in the height of the function. The slope always stays constant, and the slope is always 0. So, since horizontal tangent lines are constant functions, and since constant functions have a slope of 0, we can therefore conclude that horizontal tangent lines have a slope of 0. Woo! Exclamation point. So in this example, we're being asked to find all the values of x at which f of x is equal to 5x squared minus 3x minus 2 has a horizontal tangent line. So there may be one x value, there may be 2, 3, or 4, or there actually may be 0. We don't know, but those are all possible. But regardless, we need to figure out when this function has a horizontal tangent line. And again, based on the last line, we know that horizontal tangent lines have a slope of 0. So first thing we need to do is we need to find the slope of this particular function. And we know to find the slope of a function, we can just find the derivative. So therefore, we can come in and we can find the derivative of our function. It is just a polynomial, so we can use the power, sum, and difference rules here to give us a derivative of 10x minus 3. Well, again, So we found out that the derivative, 10x minus 3, is the formula to find the slope at anywhere on this particular function. But we don't want to find any slope. We're trying to find a specific slope with that slope being 0. So that means all we need to do is set this formula to be equal to 0, and that will tell us where on our graph the slope will be 0, which means we will find our horizontal tangent lines. So we just have to solve the equation. 0 is equal to 10x minus 3. So we can get x by itself by adding 3 to both sides. And that's going to give us 3 is equal to 10x. We can then divide both sides by 10. And that's going to give us x is equal to 3/10. So that means that at the point at the x value, x equals 3/10, we're going to have a horizontal tangent line, and therefore we have answered the question. All right, next up, for which values of x does f of x equals 7/3 x cubed plus 3x squared minus x minus 9 have a horizontal tangent line? So we're going to repeat the process. We know we're looking for a tangent line, so we're looking for where the slope is 0. And since the slope is the derivative, all we need to do is find the derivative, set it equal to 0, and solve for x. So first step, find the derivative. And we have a derivative of a polynomial here, so we can just, use the power rule, sum and difference rule. And let's see, 7/3 times 3 is going to just be 7, and then x squared plus 6x minus 1. And there we have our derivative. Now we have our derivative. Notation super important. Almost blew it there. And in order to find horizontal tangent lines, we just have to set the derivative equal to 0. Because again, derivative represents slope. So now we just need to solve this particular quadratic equation. And there's multiple ways we know that we can solve a quadratic equation. We can use the quadratic formula because that always works, but that is a little bit lengthy and time-consuming. So first off, we want to see if we can factor this out. So I prefer to use the diamond method of factoring. If you're familiar with this method, great. If you have your own way of factoring, please feel free to use that. But in this top compartment, we're going to put our a value times our c value, which ends up being -7. In this bottom compartment, we're going to put our b value, which is 6. And let's see, on the two side compartments, we're looking for two numbers that multiply to be -7, but add to be positive 6. So let's see, that's going to be 7 and negative 1. 7 times negative 1 is negative 7. 7 plus negative 1 is 6. So that means we can write our factor out as being x plus 7 times x minus 1. But if you notice here, if we did do x times x, we would not get 7x squared. So we need to continue working our diamond method here. And our diamond method says that the next step is we're going to take the a value, and we're going to divide both of our factors by that a value, giving us 0 is equal to x plus 1 times x minus 1/7, because we can't divide 1 by 7. And then since we do have this fraction here, we want to move this 7 to be a coefficient, and that gives us our factored form of our equation. And since it is broken up into factors, we can now take each factor, we can set each factor equal to 0, and solve for x. So let's see, we're going to get x equals negative 1. And let's see, this is going to be 7x equals 1, or x is equal to 1/7. So this means that we're going to have horizontal tangent lines at x equals negative 1 and x equals 1/7. All right, then our last example here is we want to determine the values of x for which f of x equals negative 3x minus 6 has a horizontal tangent line. So, same as before. Since we're finding horizontal tangent lines, we know we're looking for where the slope is 0. In order to find the slope, we need to take the derivative and then set it equal to 0. And our derivative in this particular function is going to be negative 3. So we'll take negative 3 and we'll set it equal to 0. And then we will, 0 is equal to negative 3, and that's a bad 0. It's like it's got a bad haircut with a strand of hair hanging down the front there. So sorry, let's just come in and fix that. Let's give it a little bit of haircut. All right, sorry about that. But yeah, here's our problem. But negative 3 doesn't equal 0. How do we go ahead and find the x value? Well, that's a good question. We don't, because as we just said, negative 3 doesn't equal 0. So the answer is there are no x values for which f of x has a horizontal tangent. I just realized I spelled horizontal wrong. And that's the answer. And that is possible. Not every function has a horizontal tangent line. And if we were to look at this particular function is a linear function. And as we can see, this particular linear function, it has no turning points. It has no places where we would have a constant function or where a slope is 0. Our slope is always going to be negative 3, so therefore no horizontal tangent lines. And since this question doesn't give us like our conventional answer, it does often, trick students into the trap. So now don't fall for it. It is possible for a function not to have a horizontal tangent line. All right, folks, that is it. That is determining where a function has a horizontal tangent line.